You know that feeling, right? You're stuck in traffic, staring at your phone, just thinking, how can all this smart tech not solve this incredibly dumb problem? Well, the answer, it turns out, isn't on our highways. It's in the bustling streets of cities a world away. Let's dive in and find out why.
So that brings us to the big question. Why do our most advanced AI models, the very ones that guide us through cities like London or LA, just completely fall flat in some of the world's biggest, busiest cities? The answer, you'll see, points to a really fundamental flaw in how we're building our so-called smart future.
All right, to really get this, we need to go to a place where traffic moves to a totally different beat. Our story kicks off in Ho Chi Minh City, Vietnam.
Okay, try to picture this. A city with 9 million people, and it feels like every single one of them is trying to get somewhere at the exact same time. That's just another Tuesday in Ho Chi Minh City. But, the real challenge isn't just the sheer number of people, it's how they get around.
See, this is what's so fascinating. Forget what you think of as traffic, neat, orderly lanes of cars. We're talking about a dense, flowing river of motorcycles. They weave, they bunch up, they move in ways that traditional traffic models, well, they just can't begin to understand. This isn't your standard gridlock. It's more like a chaotic, fluid system. It's beautiful, but it's a nightmare for an algorithm.
And that unique environment leads us straight to the heart of the problem. The tools we're using are just fundamentally wrong for the job.
And here it is, the core issue. Our smartest traffic AIs, they were basically raised on a diet of data from cities packed with cars. They were taught to recognize tidy lanes of sedans and trucks, not the organized chaos of a million motorcycles. And this comparison just lays it all out so perfectly. On one side, you have these standard datasets, like the ones from Los Angeles, using super accurate, high-res sensors on highways. On the other side, you've got the reality in Ho Chi Minh City. They're relying on these pretty basic, low-resolution public webcams, trying to understand a completely different type of vehicle. It really is like trying to teach an AI to recognize birds by only showing it pictures of fish. It's just never going to work.
So, this is where a team of researchers saw a huge opportunity. Instead of trying to hammer a square peg into a round hole, they decided to build a whole new tool from the ground up, one that could actually make sense of this chaotic reality.
So they created something called the Ho Chi Minh City Traffic Dataset. You can think of it as a whole new language for AI, a language that speaks fluent motorcycle. And this isn't based on some pristine data from a lab. No, it's built from the gritty, blurry, low-res camera feeds that the city actually has. It's a data set for the real world. So how'd they pull this off? Well, first, they grabbed over 1 million images from the city's existing public webcams. Then, they took a really powerful vision AI and basically sent it to school, training it to become an expert at spotting motorcycles, even in these super crowded, kind of blurry scenes. And finally, and this is the key part, they created a map of how all these cameras are connected by the city's road network. And this is where it gets really, really clever. By connecting the dots between all those cameras, they essentially built a digital nervous system for the city's traffic. Every camera is like a nerve ending, sending signals. So the model doesn't just see a jam on one corner, it starts to understand how that jam is going to ripple out through the entire system. It's not just seeing traffic anymore, it's feeling the city's pulse. Of course, building this amazing dataset is only half the battle. The real question is, does it actually work? Does it give us better predictions? Let's take a look at the results. And the result? A massive success. The new models, the ones that could see the whole city as an interconnected network, they were able to slash the prediction error rate by up to 23%. Now, in the world of traffic prediction, that isn't just a small improvement. That's a huge breakthrough. So, why was it so much better? This table really tells the story. Traditional models are kind of nearsighted. They only see one intersection at a time, completely in isolation. But these new graph-based models, they have a bird's eye view. They get that a traffic jam starting at point A is absolutely going to cause a problem at points B, C, and D down the road. They see the connections. And what you get is a model that is just so much more in tune with what's actually happening. Like it says here, its predictions really do hug the ground truth. It can anticipate the chaos of rush hour and the lulls in between with way more accuracy because it's not just guessing anymore. It's actually understanding the city's rhythm. This is way more than just some cool academic project. This work has really profound, real-world implications for how we can build smarter and, frankly, more equitable cities for everyone. And this is about so much more than just getting home a few minutes faster. This is a blueprint for the future of urban planning.
We're talking about smarter traffic lights, more efficient bus routes, and a model for cities all across the developing world. At the end of the day, it's about building AI that actually serves everyone, not just the wealthy cities where the tech was first developed.
And that, right there, is the biggest takeaway. The solution wasn't just about getting better cameras or more expensive hardware. It was about smarter thinking. It was about building a solution that fits the messy, complex, brilliant reality of how millions of people actually live. It's about making our technology adapt to us, not the other way around.
And that kind of leaves us with a really fascinating thought to chew on. This project proved that we can teach AI to find the order inside the unique chaos of a city dominated by motorcycles. So if we can crack a problem this complex, with these kinds of real-world limits, what other massive urban challenges are suddenly within our reach?